In this example, we need to find the full range Fourier series expansion for the ft function, which is equal to t here, that is from 0 to 4. So you have the tau equal to 4, which is the finite interval. For the full range expansion, we let the full range period equal to the tau, which is 4. Therefore, this is the original function t here, and this is one period. Then we repeat this signal and expand it to other intervals. So this is the Fourier function that we obtain from the full range expansion, where you have half period equal to 4 over 2, which is 2. And then omega is equal to 2 pi over p. Substitute p equal to 4 inside, we obtain pi over 2. Next, we can apply the full range Fourier series expansion by using this formula. Substitute L equal to 2, tau equal to 4 here, then you obtain this integration. Integrate t, you obtain t squared over 2, and then substitute the limit inside, and minus with limit 0 inside, you obtain 8. So after you do the calculation, you obtain the answer to be 2. We continue to find the an by using this formula. Substitute L equal to 2 inside, tau equal to 4, and then omega equal to pi over 2 here. Then we need to solve this integration. We can solve this by using integration by part. Let u equal to t here, and the remaining term to be dv. Differentiate u, you obtain dt, and then integrate dv, you obtain v. Over here, cos, you have sine, and divided by the coefficient inside. By using the integration by part formula, you have uv minus v du. Substitute your u, v, as well as the du inside. Then you shall obtain this. Substitute the t equal to 4 inside, you obtain 2 pi n. Sin 2 pi n will be equal to 0, because if the t is equal to 2 pi, this is your sine function, it will be equal to 0. For any integer number of n, the sine 2n pi will be always equal to 0. Therefore, you obtain 0 here. Then substitute 0 inside. Sine 0, you obtain 0 as well. So 0 minus 0 here will give you 0. Then you have negative here. So for this part, integrate sine, you obtain negative cos, and you need to divide by the coefficient inside. Then you should have n pi over 2 squared. Substitute 4 inside, you obtain cos 2n pi, and negative here become positive. So you should obtain this term. Cos 2n pi will be always equal to 1 for any integer number for n. Therefore, this will be equal to 1. 1 minus 1 here, you obtain 0. This is the formula for the Bn. Substitute the L, tau, and omega inside. You should obtain this. You can perform the integration by part to solve the integration. Let the u to be t and dv to be sine term here. Integrate dv, you obtain v. Integrate sine, you obtain negative cos, and then you need to divide with the coefficient inside. Then you have the formula uv minus integrate with v du. Substitute t equal to 4 inside, you obtain negative cos 2 pi n here. And then substitute t equal to 0 inside. So since 0 is here, 0 multiplied this term will be obtain 0 as well. Then you should obtain this answer, and cos 2 pi n we know is equal to 1, so substitute inside, you obtain negative 1 over n pi over 2. Integrate the negative cos here, you obtain negative sine, and you need to divide with the coefficient inside. So this coefficient is same with this coefficient, therefore you obtain n pi over 2 squared. Substitute t equal to 4 inside, you obtain negative sine 2 pi n, which is equal to 0. Substitute 0 inside, so we know sine 0, you always obtain 0, therefore this term is 0. 4 divided by pi over 2 here, you obtain 8. So you have negative here, negative 8 multiplied with 1 over 2, you obtain negative 4. So you have negative 4 divided by n pi. So this is your final answer. Then you need to substitute all the coefficients into this formula. Since your an is equal to 0, so this term can be cancelled. Previously you obtained the a0 to be 2 and bn to be this answer. There is a typo here, this should be positive. You can further simplify this formula by taking the constant negative 4 over pi outside the summation term. Then you should obtain this term here. Substitute n equal to 1 inside, you obtain this, which is sine pi over 2 is the omega. So n is 1. And then you continue substitute n equal to 2 inside this term, you obtain 1 over 2. And then 2 multiplied with pi over 2, you obtain pi. And then substitute 3 inside, you obtain 1 over 3. And then 3 multiplied with pi over 2, you obtain 3 pi over 2, and so on. So this is the Fourier series expansion result for the full range expansion for this original signal. So since this original signal is only valid from 0 to tau here, which is 4, therefore this ft function is only valid within 0 to 4.